Hello, everyone. Welcome to Differential Equation course. Okay, so we are going to learn section 1.1 and section 1.2. So 1.1 is very short. What is differential, differential equation, right? So it's an equation that contains one or more derivative of an unknown function. So how do we describe that derivative of unknown function? So we did that in calculus 1, right? So y prime over x, which is the same as dy over dx, and dx over dt, which we can read derivative of x respect to t, right? dx over dt. So x prime over t, which is velocity, right? Velocity of the function. And more derivative, we have a second derivative, right? So d square y over dx square, and we have dx, sorry, d square x over dt square, which is x double prime over t, which is the same as um, the first derivative of a velocity, which is the same as acceleration, right? So we went over this in the calculus 1. That's why I brought up here, because this is a familiar for us, right? Okay. Differential equation we are using for mathematical model, population growth, decay, and there's a new word. Let me pronounce correctly. Malthu Malthusian model. So those are growth and decay, and there's a heat flows and cooling. We're gonna learn this course, Newton's law of coolings and rate of change, glucose. Oh, this is a hard pronunciation too. Absorption by the body and spread of epidemics. And we just talked velocity and acceleration, Newton's second law of motion. And there is the interaction, species, and competition. So we are using differential equation for that. All right? And we're gonna learn everything in this course. Okay, that's the 1.1 introduction. So let's talk about 1.2. So basic concept. So every time we learn terminology and definition, right? And then formula, right? So we follow of that. So 1.2 basic concept. So once again, what's a differential equation? So it's an equation that contains one or more derivative of unknown function. So what this means? This means the equation describes how a quantity changes, because we had a dx over dt and dy over dx, right? So how quantity changes by relating a function to its derivative. Yeah, make sense? Okay, then we have another terminology, order. Yeah. So what is order? Order of differential equation is the order of highest derivative that contains. So we're gonna read how many order. So is it first or second? So we talk about the derivative, right? So first derivative, second derivative. If highest one is the second derivative, then second order. If we can see that only first derivative, then first order. Make sense? Okay. Now, in this course, we have all ordinary differential equation. So kind of ordinary is omit. That's why we called differential equation, right? So we are learning only ordinary. So what is ordinary means? Ordinary differential equation if it involves a known function of only one variable, and then we have another type which is partial differential equation. So derivative with more than one variable. So, but then we are learning only ordinary. So derivative involve only one variables, right? Okay, so let's take a look differential equation of a form with first order. So dy over dx means that derivative y respect to x, right? So we call this is f of x. Hold on 1 second. Why f of x? Not y is not the f of prime of x. Okay, so this means it's a given function. You guys understand what it means, right? So normally we have dy over dx, which is the same as f of prime of x. But then in that case, just equal to f of x. That means it's a given function. Make sense to you? Yeah, for example, looks like this. So if we have dy over dx equal to x squared, then in that case, f of x, which is x squared. Make sense? This is f of x. Yeah. And then also we can rewrite dy over dx, same as y prime, right? So y prime of x, basically, right? So we want the derivative y respect to x. Yeah. Okay. Now let's talk about the example of orders. So we talked about the orders earlier. So highest derivative, right? So look, what's the highest? Dy dx, first derivative, right? So that will be first order. Make sense? Okay, so this one we can express dy over dx equal to x squared, right? So first order. How about this? We can see that dy over dx, that's the highest derivative, right? So there will be dx equal to negative 2 minus 2xy squared. Yeah. Also, first order. How about this? We can see the highest derivative is second derivative, right? So second order. So we can express this one as d squared y over dx squared equal to 2x minus 2 dy over dx minus y, right? So second order. Yeah. Okay. Would you like to try this one? Number 4. Okay, we can see the 3, right? So third order. So, so we can use the 3, right? So we can use the 3. Yeah, after 4, we can use that number. Yeah, because too many the line, right? Equal to sine x minus y squared. So we want to make the form, then divide by x every term. So we can have that. Sine x minus y squared over x. Yeah. So third order. And spell third. Okay, number 5, we have nth order. Let's take a look. Nth order derivative, right? And this form is that. So yeah, basically the right side, sine x, x, 2x, in the case, right? In the case, negative 2, yeah, x squared, which is f of x, right? Yeah. Okay, now we have a first order, and then look, linear. Okay, first order linear. First order means that y prime or dy over dx, yeah? So only the one derivative, right? First derivative, not the one derivative. First derivative, yeah? The form is y prime plus p of x, y equal to f of x. So f of x we had earlier, given function, right? Okay, now the y prime plus, we have a polynomial p of x. So we are using first letter p of x, yeah? The form of first order linear, y equal to something, that's a linear, right? Y squared is not the linear. This is a parabola. Y to the third power is not the linear, right? So linear is just y. Make sense? Okay. What highlight linear? Okay, so let's take a look example of linear. So this is a linear, right? And this is the first order. This is also first order. Because we can see the highest derivative is first derivative, yeah? And then look, this is the form of, right? Y prime plus p of x polynomial. Then we have y. Y is telling us linear, right? And the function. Make sense to you? So the form, let me write down, the form of linear of first order. This is a stars, by the way. The form of first order linear, yeah? Y prime plus p of x polynomial y equal to the given function. Make sense? Okay, given function. Okay, now, example of a non-linear. But then in that case, it's the first order, right? So we can see the first order, but not linear, right? Look, um, we see that y squared there, right? So it's not. And then uh, this one is a product of y and y prime, right? Okay, if we make y prime, then we divide by, right? So 1 over 3 is not the linear, right? Linear should be y. Yeah? Y over 1, which is y, right? Not the 1 over y. Make sense? Okay. Now, we don't see the y as a linear. here in that case, right? So we have e to the y function, exponential function there, right? So this is non-linear, but it's a first order. We can see that, right? So y prime, y prime, y prime. Make sense? All right. Okay, now, then, so this is first order linear form, which is y prime plus polynomial times y equal to the given function f of x, right? What about the second order linear, right? Then we have y prime polynomial. So we are using p of x. Then first prime and polynomial and linear y and given function f of x. Yeah. So it's kind of reduce the degree, right? Second prime, first prime, y equal to the function. Make sense to you? Okay. Then if we are following the pattern, what is the form of higher order linear, right? Okay, so nth derivative, that's the highest order, nth derivative, right? Plus, and then reduce by one, the derivative, until y, we have to have y because linear, right? And then any polynomial we are using it, right? So we make a notation, any polynomial. We can use a P, we can use a Q, we can use A, B, C, whatever, right? Yeah. So just a linear. Is it clear? Okay. Now, terminology. So we have a solution. So differential equation. So let me denote DE. Yeah, because it's a long name, differential equation, like a course subject, right? So first letter D, second letter, I mean the first letter from the second word. Yeah. Okay. Thus, a solution of differential equation is a function that satisfied differential equation on some open intervals. Okay. So they have, so this is just general definition, right? So we are going to actually do examples so that we understand solution, right? Okay, y is the solution of, the y is n times differentiable, and then the form is that, right? Okay, should it be open interval? So y is the solution of open interval, parentheses, open, close bracket, right? So the graph of solution of differential equation is solution curve. Okay, all right. So let us do the first question. So verify that this is the equation. Can you see that y is the solution on this open interval, right? Okay. Now, is this y equal to this equation solution of that on open interval, right? Okay. Now, how do you do? So basically, it's like this. We have equation. That's y. Name is y, right? So this is y. So we plug into here. But then we have a y prime there. And then we don't know what is the x. So we leave x there. Make sense? And then whether that equation make other side x squared, right? So we check that. Check it out. That's my signature. Check it out. Yeah. Okay, let us do that. Okay, so in order to do that, we have to know y prime. Yeah. So what is y prime? Note. Y equal to x squared over 3 plus 1 over x. And then y prime. Haha. Been a while, well? So what is y prime? So 1/3. So basically we have a 1/3. That's the constant. So drop the power, reduce by 1, right? So 1/3, drop the power, reduce by 1, plus, and then 1 over x. So, okay, so it's been a while after a break. Let us do that. How about this way, right? X squared minus x, plus negative x, yeah? Then drop the power, reduce by 1, so x, -2, yeah? Clear? Okay, then that will be 2/3 of x minus 1 over x squared, yeah? Okay, now we have xy prime plus y equal to x squared, right? So we check that. So x, y prime, 2/3 x minus 1 over x squared. Am I recording? Yes. Okay. Plus y. What's the y? Y is x squared over 3 plus 1 over x. So we want to check whether this is x squared, right? So basically we plug in, yeah, y prime and y. Okay, so let's calculate. So we do derivative, so 2/3 x squared minus simplify, so 1 over x plus x squared over 3 plus 1 over x, yeah? Okay, so we have 2 and 1, so 3 over 3x squared, right? 3 over 3x squared. And this one is 0, right? 0. Which is x squared, right? Then, which is the same as, right? So yes. So we can say that y equal to x squared over 3 plus 1 over x is the solution of that differential equation in open interval, right? Make sense? Yeah. So let me just copy and paste. Copy, paste. Does. Yeah. All right, next one. Okay, so we have a find k where x over t equal to k is a solution of, this is a differential equation, right? Okay, so look, same concept. Earlier we have y equal to given equation, right? And we had y prime. So we found y prime and plug in there. And then we plug in, substitute y. And then whether this one is the same as x squared. Yeah. So whether this is a solution of this interval, right? So this interval, why they did not include zero? Because we don't want actually the zero in denominator, right? So we don't include the zero, but all real numbers in the open interval. Make sense to you? Okay. So same as here. So dx over dt, so that means x prime over t, right? Okay, then we have x. We have x over t equal to k, right? X prime over t. How do you find? They said k is constant. We derivative of a constant. What do you get? Very good. It's zero, right? So it's zero because k is constant, right? So k is constant. All right. Okay, then. So we have, let me copy. Copy. So there will be 2t to the third power. And then this will be, oops. Oh my gosh, no. Let's go. T2 to the third power. And this will be 0. Same as x prime of t, right? And plus 6x plus 3, right? Okay, look. They say that x equal to k, so we replace this x equal to k. Yeah. All right. So this will be k since x over t equal to k. All right. So we have 6. This is a 0, right? So this is a 0. We have a 6k plus 3. Now we can start for k. Easy, right? So now 6k plus 3 equal to 0. Sorry for k. So we have a 6k equal to negative 3, which is k equal to, what do you get? Negative 1/2. Very good. like earlier, y equal to something is a solution of a differential equation, right? So we can have that this is x over t equal to, so x over t equal to k, which is negative 1/2, is a solution of, let me just copy for this one. Yeah, copy. All right, make sense? Okay, now would you like to try this one? Okay. Look, we can substitute this one, right? So now we need to find what is the y prime, and we need to find what is the second prime of y. Then whether we get the 0 or not, right? Oh no, we need to find the k, such k there. Yeah, like earlier. Okay, let us do that. Okay, so try, we have note. And then go bigger. Y over x equal to e to the kx. Yeah. Okay, so y prime over x. So e to the kx. Then times k, right? Right? Okay. So second prime. So we derivative y respect to x. Yeah. So k e to the kx times k, right? So there will be k squared e to the kx. Yeah. Okay, now we have, oh, let me copy. Okay, so we substitute everything there. So y second prime first, y second prime first. So there will be k squared e to the kx minus 12. Y prime will be k e to the kx and plus 27y, which is e to the kx. So we want to check that whether equal to 0. Yeah? Okay. Oh, no, no, no. Sorry. Once again, we have to find a k, right? Such a k. I said earlier, and then do again. Okay, equal to 0. We need to find the k, right? So solve for k. All right, solve for k. Solve for k. Okay, so we have k squared e to the kx minus 12k e to the kx plus 27 e to the kx equal to 0, right? Okay, now we need to solve for k, right? Okay, so every term has e to the kx, right? So let's divide by e to the kx, e to the kx, e to the kx. Yeah. So we have a k squared, oops, e to the k, oh, we divide. So k squared minus 12 plus 27 equal to 0, right? Okay, so we can factor out. So can you think about that? K 27, 9 and 3, and negative, negative. Yeah. So k minus 9 equal to 0, k minus 3 equal to 0. So k equal to 9, k equal to 3. Yeah. So let me just omit the conclusion because we knew how to conclude. Okay. Now, initial value problems. So we have this one, initial value problems. Okay, so we have find solution. So far we had, is this solution of that, right? So that was warm up, right? Now we're gonna find actual solution with a given differential equation, right? So y prime equal to x to the third power. And then they give us initial value, initial condition. Yeah, okay. So the processing is a little bit different with the previous one, okay? Yeah, it's like this in algebra, right? Is it x equal to 3 equal to y equal to 3x to the fourth power minus 2, right? Is it x equal to 3 is a solution of that, right? Then we plug into 3 into the function or equation, right? To find out. Yeah, maybe I made incorrect, not improper the example. Yeah, but concept is like that, right? Okay, now we're gonna find actual solution. Okay, how do you do? All right, so y prime equal to x to the third power is given. Now, look, let's go back to the first example. So we have y equal to, right? So is it y equal to? Now we have a differential equation, right? And first order. Yeah. Okay. So basically we want to find what is y. Is it clear to you? Okay. That is a solution because we say that y is, this one is a solution of that differential equation, right? Okay, so now first order, okay, now how do you make y equal to? That's the goal, right? What do you think? Okay, so I wrote down the goal. Looks like that, right? So y equal to the equation like this example. Okay. Okay, so we have y prime equal to x to the third power. How do we find from here to y? Very good. So we do antiderivative, right? So that will be both sides. Yeah. So y prime equal to x to the third power dx. Yeah. So what do you get? The left side. So that will be y. Good. Okay. Now y equal to antiderivative, right? So reverse from derivative. So we add 1 for the power, divide by new power, right? So that will be x to the fourth power over 4 plus c. Yeah. in that case, we need to find that such a constant. That's what we had earlier. Find the k such that, and so on, right? Okay. So we had a warm up earlier. So we can find such a c by using their information. Okay. So y over 1 equal to 2. Yeah. Not the over of. So y over 1 equal to 2 means x equal to 1. Yeah. So there is x. Okay, so we have y over x equal to x to the 4 over 4 plus c. Then y over 1 equal to, we have 1 over 4 plus c. Okay, then in that case, we have y over 1 equal to 2, right? Okay, so we can find such a c. All right, so what is a c? So 2 minus 1 over 4, right? Equal to c. So common denominator, so 4. So a minus, so we have 4. A minus 1, which is 7 over 4. Yeah, make sense? Okay, so we can conclude. Let me write down, because my handwriting is so big. Yeah. Let me add. So y equal to x to the 4 over 4 plus 7 over 4 is a solution of the differential equation, which is y prime equal to x to the third with y over 1 equal to 2. Yeah. Okay. Now, we have form of initial value problem for higher order differential equation, right? So this is a second order, and then we have a differential equation, and this is a given function, which is f of x, right? So initial values y over 0 equal to 1, y prime over 0 equal to 2. That's the initial values, or we can say the initial condition. Yeah. So let me arrange a little bit. Okay, so this will be last question in this section. So a tank contains 60 kilogram of salt and 2,000 liters of water. Pure water enters a tank at the rate 8 liters per minute. The solution is mixed and drains from the tank at the rate 9 liters per minute. Let Y be the number of kilograms of salt in the tank after T minutes. The differential, not differential, it is differential, differential equation for this situation would be dy over dt equal to, what is that? And then we need to find the initial value, initial condition. Okay? Okay. So the goal is dy over dt. So that is, what is the rate in inflow, and we subtract what is the rate out, outflow flow, right? Okay. Uh, let's see. So the tank contains 60 kilogram of salt. That means, um, look, why be the number of kilograms of salt, right? So after 10 minutes, so we have y over 0 equal to 60 kilogram, right? Make sense? So means y, um, so y over t by the t is minute, right? So equal to y over, not over, y of 0 equal to 60 kilograms. Yeah, 10 minutes. T equal to 0, 0 minutes. Make sense? Yeah, that is the initial value, initial condition. Yeah. Okay, so let's find out what is read in and read out. Okay, so we have read in, rate pure of water entering 8 liters per minute. We have rate of solution draining from tank 9 liters per minute. And then initial amount salt when t is the time minutes, right? So while of 0 equal to 60 kilograms of the salt. Yeah. Okay. Let's see. Okay, so I wrote down here as well. We have a volume of a solution in the tank, the 2000 liters. So 2000 liters, we have 60 kilograms of salt and 2000 liters of water, right? And then pure water enters 8 liters per minute and then drain 9 meters per minute. Okay, so we have 8 liters per minute, that's pure water. What about the salt? We don't know. I didn't, I should not say that we don't know. So zero salt because it's a pure water. Make sense? Okay. So we wrote down 0 kilogram for salt per liters. Okay. So we have a rate of salt leaving the tank. It's given 9 liters per minute. And then we want to express it in terms of y because they say that let y equal to number of kilograms of salt in the tank. Yeah, in terms of the time t minute. Yeah, so we have a kilograms. So y kilograms. So we have y kilograms from where? Total volume, right? So how do you find the total volume? So it was in the tank 2000 liters, right? So 2000 liters and we pour the, what is called? The pure water. So plus 8 liter per minute, right? So liter per minute. And then drain 9 liters per minute, right? Okay, so we express this one will be, oops, 2000 L, the liters, and negative 9. Oh, no, negative 9, negative 1, right? So negative 1. So it's a negative 1 liter per minute, right? Okay, so let's take a look this one. Negative 1 liter per minute means they are losing 1 liter per minute. Make sense to you? Let me write down this one. So means lost. Uh, lost 1 liter per minute, right? So then we can use this one is negative T. What do you think? Same as, right? Per minute. Yeah. Losing 1 minute, 1 minute, 1 liter per minute. Yeah. Negative T. Make sense to you? Okay, good. All right. So let's writing out rate in. There will be 0. Make sense? Because we times this one, which is 0, right? So let me make this one here then. Copy. Shorter a little bit. Okay, rate out, which is minus rate out 9 liter per minute times y kilograms over total volume, which is 2000 liter minus T, right? So we understand what is the T come from, right? Okay. Now, let's simplify, yeah? So there will be the first term, parenthesis is 0, right? So there will be negative 9 and over, yeah, let's take out the unit. So there will be 9y over 2000 minus t. Yeah, is okay? Oops. Oops. Yeah, okay. The unit is a kilogram. Yeah, that unit. Let me see. Okay, so let me see. Okay, so the negative 9 has a unit, the liter per minute, right? And so this is liter per minute. And then we have this one has kilogram per minute, right? Make sense? This one, kilogram per unit. I'm sorry, kilogram per limit. So kilogram per limit. Yeah. So we simplify, then we get kilogram per minute. Make sense? Okay. So I wrote down one tip for your homework, so please read. Thank you for watching. I will see you in the next section. Thank you. Bye.